All right, we're going to talk about section 2.6, transformations of functions. So in this section, we will be talking about taking a what we'll call the parent function and moving it up, moving it down, moving it left, right, stretching it vertically, compressing it vertically, and also reflecting it. Okay, so we'll look at all those different situations. Desmos is definitely going to be your friend here, but your graphing calculator will do a similar thing. The screen just won't look as pretty when you do it. But I will be showing you in Desmos just because the visuals are better. So describe the translation in this function as it relates to its parent function. Let's first talk, before we get too far here, about what a parent function is. So the parent function is the simplest version of a family of functions. So what is a family of functions? Well, there's a number of them, probably like a dozen. Okay, one family of functions is linear functions. All the lines that you've ever graphed are called linear functions. And the parent function, the parent linear function, is y equals x. That's the simplest version of a linear function. The parent version of a quadratic function, so a parabola, is y equals x squared. The parent function of absolute value is y equals absolute value of x. Okay, so you can see that with all of these functions, we could add numbers to them. So we could add 7 to this. We could subtract 16 or any number that we wanted. We could take and multiply this number by, or this function by 4 or 2 or a half. And all of these things would impact the graph in different ways. And what we want to look at in section 6 is how do those things change the graph of the parent function. All right, so let's look at this absolute value of x plus 2. In fact, let's zoom in a little bit so you can see it a little bit better here. Okay, so to graph this, what we're going to do is, what I like to do is compare it to its parent function. Now, both in the same window. The more of these that you do, the less you will have to graph, because you'll just kind of pick up on the patterns and what's going to happen. But for right now, let's just graph the absolute value of x. That's the parent function there in red. All right, and then let's graph absolute value of x minus 2, and make sure that you're outside of the parentheses, or sorry, plus 2. Make sure that you're outside of the parentheses. That will make a big difference. Okay, and so you can see that that graph is just moved up 2. So describe the, let's see, so then we'll graph it. So what is the description here? Well, it's been vertically translated by 2 units. So we'd say vertical transformation. Here, you know what, actually, you can just say vertical shift. So vertical shift of plus 2. Okay, so that means it's been moved up 2. I should say real quick before we get too much further here. This box down here has kind of the vocabulary for it. So you can say horizontal translation, vertical translation, or like I said, shift is fine instead. It's shorter to say. All right, and there's some function notation stuff in here. I don't think you really need to pay too much attention to this. I think just doing some of them and getting used to how the functions changes is the best thing to do. The last thing I have to say about this box is here we have stretch vertically and compress vertically, but it's in the dilation section. This is the vocabulary I'm going to be using primarily because it's I think it helps you visualize it better, stretching a graph vertically or stretching it or compressing it vertically, right? So when we get to some of those, that'll make more sense. All right, so anyway, this is a vertical shift of positive 2, and so the graph is going to look like this. Okay? All right, let's do another one. Describe the translation in this function as it relates to the parent function, then graph it. Okay, so the parent function here is y equals x squared. You can see that because this is very close to being just x squared, but we've subtracted 4 inside of the parentheses. That will make a big difference, whether it's inside or outside. So you should take a look at this graph and see if you can describe the transformation or the translation. So this would be x minus 4 squared. All right, so if we compare that to x squared, you can see that the graph has been shifted to the right 4. So we'd say shifted right 4 units. Okay, and then we can just real quick turn this into a table, grab a couple of points. So we have 1, 9, and we have 0, 16. I can't graph that. And we have 2, 4. So over 2, up 4. And then I suspect that we will have 3, 1, and 4, 0. And we'll do the same thing going this way. So just a sketch is fine. We don't have to get super picky with the points, all right? So it's been shifted right 4. Let's go on to the next one. Describe the translation in the graph as it relates to the parent function. So again, the parent function here is y equals x squared. We're going to see what happens when we stick a negative in front of the graph of x squared. So let's clear that out. There's x squared. Here is negative x squared. And so what we have there is a reflection over the x-axis, okay? And if you look at the little box at the bottom, there's 2 types of reflections, about the x-axis and about the y-axis. So this one is a reflection over the x-axis. And again, looking at the graph here, you can see that it's just been flipped over the x-axis, right? And so again, just a sketch is going to be fine. 0, 0, negative 1, 1, and something like this. It's not beautiful, but it should be fine. All right, next one. Describe the translation in this function as it relates to the parent function. Again, x squared is our parent function. We're going to switch this over to 4x squared. And what that'll do is it will compress it, it will stretch it vertically. Look at the purple graph, which is x squared, compared to the blue graph, which is 4x squared. You can see it's almost like you took the purple graph and you just pulled on it, and it got narrower. Okay, so we would say that this has been stretched vertically. And then I don't care too much about this, but sometimes the book will ask, we'll say by a factor of 4. Okay, so how much is it getting stretched vertically? Well, it's a factor of 4 because we're multiplying the whole thing by 4. All right, and again, if you want to pick a couple points here, there's probably not going to be many that we can graph. 0, 0, 1, 4. It's going to go really fast, and negative 4, and there's your graph. Okay. All right, next, describe the translation in this graph. So let's compare again x squared. And we're going to compare 1/3 x squared. This has to go inside of the parentheses. So we have 1 divided by 3 x squared. All right, and you see what this has done. It is, instead of stretching it vertically, what this has done, it's almost like you've taken the purple graph and you've squeezed it. You've compressed it vertically. Okay, so we'd say this is compressed vertically. By a factor, and then whatever the factor is that you're compressing it by. So this one would be 1/3. Okay. Last one here. We're going to try and tie. Oops, I never drew the graph here. I'm sorry. Turn that into a table real quick. Get some points. So 0, 0, 2, 1.3. So that's like right here. Same thing over here. So you get this something like that. Again, not super picky about the graphs. All right, moving on. Last one, we're going to try and tie a bunch of stuff in together here at once. So we have, and we've got to be very careful with parentheses in both Desmos and in your graphing calculator, if you're using your TI-83 plus or 84 or whatever. -1 squared, and then +4. Okay, so what's going on here? In fact, before we analyze the graph, let's just look at what's going on here generally, all right? I've got a negative out in front. We saw earlier in this problem up here that the negative out in front makes the parabola reflect over the x-axis. So we would expect this parabola to be pointing down. Okay, again, we're comparing this to x squared. We would expect it to be pointing down. What else is going on? Well, we saw in an earlier problem up here that when we added 2 to outside of the function, it shifted it up, shifted it vertically by a factor of whatever we added. So we would expect that this graph would be shifted up 4. And then this inside of the parentheses putting the 1 in there shifted it horizontally up here in number 2. When we did x minus 4, it shifted it to the right 4 units. Okay, so what we would expect here is that this would be shifted to the right 1 unit. Okay, so when we graph it, we see that that is in fact the case. If you imagine flipping the, well actually let's back up. So you can see here that it's been shifted right 1 and up 4. Okay, that point right there is 1 comma 4. And then when we put the negative in front, you can see that it's going to flip it over. Okay, so just based on looking at the function g of x here, you can predict what's going to happen to the function. So we'll plot some points and then we'll describe this in words. So we've got 0 or negative 1 0. We've got 0 3. We have 1 4. And then we have 2 3. And you can see that that pretty much gets you what you need to sketch it as it flips down. All right, and then how are we going to describe this in words? Well, as I kind of already alluded to, this is reflected over the x-axis. It is shifted, so shift, what did we say, right 1. And it's shifted vertically, or I guess we'll just write vertical shift. Of plus 4. Or you could write shifted up 4 units, or shifted vertically positive 4 units, or up 4 units. However you want to say that, it's fine. I'm not super picky about that. Where you really got to be careful is when we're talking about being compressed or stretched vertically, right? That can sometimes, students will flip those around for some reason. But yeah, so that's what you're going to do. You're going to compare these functions to the parent functions, and you are going to sometimes have to write it out. Sometimes you'll have to graph both graphs, but that's basically it for section 6. It's graph it, compare to the parent function, and that's it.